Okay, I hope you gave this challenge a go, because it's kind of a fun one, finding bad movies that have done the most damage to humanity. So let's go to my pig view here, and I'll show you my solution. And I stored this as most rated 1-star movies. So here's my solution. Let's blow this up and take a look at it. And I'll just walk you through what it's doing. So a lot of this code looks very familiar. It's very similar to our previous example, like I said. So hopefully this wasn't too hard for those of you who are at least comfortable with coding to some extent. For those of you who aren't, follow along. You might learn something. So we start off loading up the ratings relation just like we did before. And we're going to just import that into a relation and name the columns user ID, movie ID, rating, and rating time. So we now have a relation named ratings that contains all the rating data. And we load up the metadata just like we did before as well, using pig storage to specify that it's delimited by pipe characters. And we import the movie IDs, movie titles, and release dates, and video release and IMDb link, even though we're not using them, but why not? And then we go through for each metadata and generate a simpler relation called name lookup. That's just the movie ID and the movie title. Now, we could have done this up here in one step. So, I was just kind of reusing my code from before here. If you chose to just load that directly as only importing the movie ID and movie title, that's fine too. That works just as well. Next thing we do, I created a grouped ratings relation that just gives me back every unique rating, every unique movie rather. We're grouping by movie ID and all of the ratings associated with each movie. Okay, and from there, I can generate the average for each movie, average rating, just like we did before in the previous example. And while I'm at it, I'm also going to store the count of how many ratings there were. So this is the main difference so far in what we did before. Instead of just creating a new average rating column, I'm also creating a new num ratings column that contains the number of rating in each group. So at this point, I have a relation that contains a group movie ID, and then the average of all the ratings for that movie, and the number of ratings for that movie. I can then proceed to filter that by only movies that have an average of less than 2.0, and I'm going to call that relation bad movies. And then I can join in the movie names and call that named bad movies. Okay. Another thing that's a little bit different from before is I didn't bother converting the release date because I'm not actually using it for this exercise. There's no requirement to sort things by release date, so we skipped that part. And we're almost done, so finally we go through the named bad movies and generate a simpler look. That's just going to be the movie title, the average rating, and the number of ratings, just to clean up our results a little bit more. I could printed that out, and I could have just sorted named bad movies and printed that out and be done with it, but we're going to make it a little bit prettier here. You didn't have to do that. Finally, we will sort the final results by the number of ratings for each movie in descending order. So this will give us the most popular remaining movies on top of our list, which should give us a sorted list of the worst movies that have been seen by the most people. And finally, we dump the results. So let's go ahead and execute this. I'm going to use a TES to make it go a little bit faster. And if you want to hit pause and study this a little bit, or compare it to your solution, feel free to do so. Like I said, there's more than one way to do it. So this isn't exactly the right answer. If the code you wrote works, it's kind of all that matters. So hope it did. Anyway, if your code does work, these are the results you should get. So that much shouldn't be any different. Okay, we've got our results here, and the results are a little bit surprising. Keep in mind, this data set is from 1998, so a lot of these bad movies have been long since forgotten, as well they should be. And it turns out that the 1-star movie that inflicted the most damage on our poor little test subjects that contributed to this data set was Leave It to Beaver, where 44 poor souls had to watch that movie and rate it, and they all pretty much agree that it was kind of terrible. So, if you do feel like punishing yourself, if you feel guilty about something, you can go through this list and watch them. Some of them I even remember. Free Willy 3, shouldn't have happened. Home Alone 3, never should have been made. Lawnmower Man 2, why? What were they thinking? I mean, the late 90s were kind of like the golden era of really bad sequels, right? RoboCop 3, there's a reason you haven't seen that on cable lately. Okay, so All Dogs Go to Heaven 2. Oh my gosh, I think they're up to like version 20 or something by now, right? Anyway, it's kind of a fun example, so I hope you had some fun with it. And that concludes our section on Pig. So you have learned Pig at a high level, and you're probably pretty good at it at this point, actually. You could probably actually do some real work. using Pig at this point. Very powerful tool, a lot easier to use than MapReduce, and when combined with Tez, it's actually quite efficient too. So congrats, you are now a Pig master. See you in the next section. So that's Pig. It's pretty fun stuff. Congratulations. These are some very valuable skills that you've been learning already in this course. So hey, we've covered HDFS, MapReduce, and Pig so far. With that alone, you already have a lot of the tools that you need to actually process and analyze big data on a Hadoop cluster. But we're not done yet. There's something even more exciting called Spark, my personal favorite of all the Hadoop technologies. So let's talk about that in our next section.